Hello guys, welcome to Solving Solutions, your number one channel where you get solutions to all your solving problems. It's nice having you in class again today. How have you been? We are going to look at Traverse Computation. We are going to see how we can use the transit rule to actually adjust a particular or this particular traverse field observation, right? Good. So there are videos on the channel where we've shown you how to use different methods of carrying out forward computations, back computations, and other traverse computations, right? Good. So on this video, we are going to show you how you can use the transit rule to correct or to compute, or let's say to adjust here, to adjust what your traverse loop, right? Good. So thanks for coming to class. If you're coming to the channel for the first time, you can encourage us by subscribing, and if you are a returning viewer, thanks for always checking up on us. So we have a question here. Given the following data, the data is actually here on Excel, right? Good. So given the following data, compute for the coordinates of the unknown points. We have unknown points pt1 to pt4, right? Good. um of the traverse using transit rule or transit method of adjusting coordinates, right? Good. And then the point we started from, that's actually the control one, or let's say one of the controls. We have the coordinates of that control, right? Good. So we are going to use that to serve as where we started from. So on this spreadsheet, what we've actually highlighted are part of the solution. Then this was actually the question given to us, right? So we have the line, we have the distance, and we have the bearing, right? Good. So the distances are in meters, and then the bearings are in degree minutes and seconds, right? Good. So we started from control 1 to point 1, from point 1 to point 2, 2 to 3, 3 to 4, 4 to control 2, and then from control 2 to control 1, right? Good. So if yours is not having any control attached to it, and then you just have from point 1 to point 4, and then from point 4 to point 1, it's still okay, right? You just need to understand what is going to be done, or how you are going to carry out what is supposed to be done, and you are good to go, right? So now for the transit rule, we are more concerned with what the delta nothings and the delta is. That's what the departure and the latitude, or let's say the latitude and the departure, right? Good. That's the delta nothings and the delta easting. So that's where our interest is actually more concentrated. And then one thing again on the channel is that we've actually shown you there are different videos. The link to that video will be on the description section. How you can use your calculator. We mean this Casio FX991ES Plus calculator, right? Good. How you can use that calculator, the physical one. Should I call it physical? Yeah, the physical calculator and the mobile application. We've shown you how to use them because we use the physical calculator on those videos, and we've actually made a video on how to use the mobile app on your phone, right? So links to all of those will be on the description section. So we are going to use the calculator. We are not going to use the L sin theta or L cos theta procedure for getting our partial coordinates. We are using the calculator to get what the delta nothings and the delta eastings straight up, right? Good. So now the first thing now is that we need to get our delta nothings and our delta eastings from the distance and bearing given to us, right? So now on your calculator, you already know the drill. You know, if you're using the Casio series, just press shift and then you press minus. You should be seeing rec being displayed on your screen, right? Good. Now that means you want to display, or you need rectangular coordinates, but your input will be polar, and the polar are actually what the distance and the bearing. So you now type in your distance and bearing. So the distance for the first line is actually what 83 204.19. So then bearing is what 83 degrees 16 minutes 58.9 seconds, right? Good. So with that, you should be having something like 28.883 displayed as your delta nothings, and 202.790 displayed as your delta eastings, right? Good. So that's how you are going to use the calculator. You use the rec command, that's shift rec. The rec is actually a second function of the minus. So you press what shift and minus, then rec will come up. Then you impute what your distance and your bearing. That's distance comma bearing, distance comma bearing, and then you should be able to arrive at these values. Please ensure you do these things on your calculator so that you can actually confirm the values we have on the screen, right? Good. So with that, you should be able to have your delta nothings and your delta eastings. Now when you've gotten your delta nothings and your delta eastings up to this last point, you are now going to carry out a sum. By the sum, we mean whatever the sign is, you are going to retain the sign. So we have what 23.883 42 plus 43.711 minus 204.859 plus 0.660 plus 26. So by the time you sum everything together, please ensure you do it. You should be able to arrive at what? 0.012. Now for every traverse loop, for every corrected or adjusted traverse loop, the algebraic sum of all your delta nothings and your delta hastings must be zero. That means if the system is free of what? If the system is free of error, maybe if you've adjusted the error, right? However, for this particular system, we have seen that we are having an error of what? 0.01. So if you don't have zero, that means the value you have is actually what's your error, right? Good. Same thing for your delta hastings. Ensure you confirm these things with your calculator. Shift rec the distance, comma, the bearing, then your delta nothings will come up first and your delta hastings follows, right? Depending on the calculator you're using. So by the time you add everything together here, you should be able to have what? Minus 0.007, which means this delta hasting is actually not what? A closed loop as well, right? We have an error of 0.007. So what do we do? That now takes us what? To the formula we are going to use. Now for the transit rule, we are going to apply corrections to our delta nothings and our delta hastings, right? Good. So now for the correction on our delta nothings is actually what? The total error in the latitude, which is actually the delta nothings, multiplied by the latitude of the line divided by what? The algebraic sum, or let's say, yeah, the algebraic sum of the latitudes. Same thing for your delta hastings, which is what? Your departure or the longitude, right? You have what? The total error in longitude multiplied by the longitude of the line divided by what? The algebraic sum, right? Good. So now what do we mean when we say so now let's try to extract the parameters where what? For the delta nothings, the total error is this. Remember that when we added all of the values here, we didn't have zero, we have what? 0.012. So that's what we have here. Then the algebraic sum. Now the algebraic sum here means you take all the values here as positive, you add them with their absolute values. That means anywhere you see negative, you use it as positive, right? So you ignore the negative sign and then you add it together as what? As positive. So by the time you add all of these your delta nothings together, you should be able to arrive at what? 409.730. Same thing as when you add all your delta hastings together, you should be able to arrive at what? 841.239. Ensure you calculate these things and you confirm it by yourself, right? Good. So now coming back to the formula we are going to use, we are now trying to extract the algebraic sum for the delta nothings to be what? 409.730. And then when we come down to delta hastings, our total error, which is this 0.007 minus 0.007, then the algebraic sum is what? 841.23 what? 239, right? Good. So now these are the parameters we have extracted. If you now look at this, if you look at this formula, you can see. Okay, let's come to this formula. If you look at this formula now, you can see that the total error is the same all through for delta hastings, and the algebraic sum is also the same for what? For delta hastings. So the only thing that is changing is what? The longitude of the line. Same thing for the latitude. The only thing that is changing is what? The latitude of the line. So for you to be able to do this thing very fast and efficiently without encountering error, we are going to suggest that you actually save some of the values on your calculator. So what do we mean by that? Now for the delta nothings, we have what? 0.012 divided by 409.730, right? Good. So you would have a value very small, 0.0000 something, right? Good. Now we are going to save this on our calculator, and the link to that video is on the description section of this video, right? For the purpose of explanation, how do you now save the value on your calculator? You press shift and then you press RCL. That shift means you are trying to get the second function of RCL, and the second function of RCL is for you to store a value, right? Good. So for us to now store this value on our calculator, we are going to use any letter of the alphabet. So on this video we are using A. So please follow through with A, so that whenever we say A, you know that we are talking about delta nothings, right? Good. So we've now stored the result we have for A in our delta nothings. We have stored the result for the delta nothings in our A, right? Good. Now let's come back to the delta hastings. We have what? Now another thing you also need to pay attention to is that when you are trying to carry out the corrections, because what we are doing now is that we want to get the corrections. When you want to carry out the corrections, you need to ignore the signs. These are a bit tricky, but you just need to pay attention. Now you need to what? Ignore the sign. So this negative sign, we are going to leave it silent, which means we are not going to look at it for now. So we are just going to have 0.007 divided by 841.239. Please press these things on your calculator. So we are still going to save this as what? Letter B. You remember the drill, right? Shift RCL, which is store, then you now press B. And then when you say alpha B, that means you're trying to recall that value, right? Good. So we have stored these two constants, which is the total error and the algebraic sum. So what we did was that the total error divided by the algebraic sum, because all of these things are multiplications, and multiplications are very easy. So when you have 1 times 2 over 3, you can also change it as 1 over 3 times 2, right? Good. So you are good to go. So we just brought this algebraic sum under the total error in latitude, so that we can be multiplying it with the latitude and the longitude of each of the lines, which is what actually alternating. Are we together? So that's actually the simple thing we've done at this point. So now we've saved our A, we have saved for the delta nothings as A and the delta eastings as what? As B. Therefore, going forward, we are now going to start working on the what? On the corrections. Now for line 1, you see that we have 223.883, and then for the delta easting we have 202.790, which means for us to have the correction for that line 1, we already have 0.012 divided by 409.730 stored as what? Letter A. Hope you remember. Good. So we are just going to say alpha A on our calculator multiplied by what? 23.883. So what value you would see, or you should see on your screen, is what? 0.001. Was that what you got? Please, if that's not what you got, you need to retry it again, right? Good. So that's value for the corrections for what? For line 1. That means on delta nothings. Now let's come to delta eastings. So we already have it stored as B, right? So we now multiply it by the alternating latitude of that line. So we have 202.790. So we're having what? 0.002. So that's what the delta easting of line 1, right? So we've gotten the correction for delta nothings and delta eastings of what? Of line 1 and of line 1 rather, right? Good. So now let's come to line 2. The same thing we have done, which is what? Alpha A multiplied by 43.711. So you have what? 0.001, right? Good. Then you come down to the eastern part, so that's for your northern. You come down to the eastern part, which is what? Alpha B multiplied by 111.702. So that's also what? 0.001. So that's how you run that through until you get to what? You get to line 6. Ensure you confirm the answers if we have actually typed anything in error, right? Good. If you've actually typed anything in error. So if all of those values are correct and you've also confirmed it, then the next thing is now for us to apply the correction to these are values here. Now remember that the error we have here for the delta nothing is what? Is positive. So since the error is positive, the correction will be negative. Pay attention to that. Since the error is positive, the correction will be what? Will be negative. So that of the delta easting, the error is negative, therefore the correction will be what? Will be positive. So pay attention to that. It's actually very, very important. Now the reason why we are having it is that when we are trying to do the multiplications here, most of the signs that are negative were silent. Like, okay, let's come to this. This should be line 1, 2, 3, 4, 5. Let's look at line 5 for delta easting. So we have what? Alpha B multiplied by 171.087, right? Good. So we are having 0.001, right? Good. We did not use this negative sign. We did not use this negative sign because we are trying to use the absolute values of all of our latitude and all of our longitude. That means all of our delta nothings and all of our delta eastings, right? Good. So when you are multiplying, you do not pay much attention to the sign. Even if they are negative, you use it as positive, because it is believed that you're trying to use the algebraic sum. You are trying to use the values you've used for what? For the algebraic sum, right? Good. So that's how it is that's how it is done. So the signs are what? The signs are silent. Now we have been able to establish what? The different corrections. We have been able to establish the different corrections for the different lines, right? So we have that of line 1, line 2, line 3, line 4, line 5, and line 6, right? So now we told you that when the error is positive, the correction is negative, and when the error is negative, the correction is what? Positive. Therefore, for line 1, since the error for delta nothings is positive, which means the correction will be what? Will be negative. Therefore, for us to now get the corrected delta nothings, it will now be 23.883 minus, what do we have here as the correction? 0.001. Ensure you confirm this on your calculator, so you should be able to arrive at what? 23.882, right? Good. Now for the delta easting, the error we have is negative, therefore the correction will be positive. So we are going to add this value to our correction. So we have what? 202.79 plus 0.002, right? Good. So you should be able to arrive at what? 202.792. So now let's pick out this line 3, right? Let's pick out the values for line 3. Now what are the values for line 3? The delta nothings. Now the delta nothings here is negative, so we are having, let's try to work on this line 3 because it's actually a bit tricky. So we are having what? Alpha a multiplied by 204.859, right? Good. So the correction for the delta nothings for line 3 is what? 0.006, right? Good. Then we come down to the easting, which is what? Alpha b multiplied by 41.149, right? Good. So to 3 decimal place we have what? 0.000, so we leave it at 0, right? Good. Now let's see how to apply the correction. Remember that for the delta nothings, our error is what? Our error is positive, which means the correction will be what? Will be negative, right? Good. So we are now having minus 204.859, then minus 0.006, right? So what the value we are supposed to get displayed on your screen is actually what? Minus 204.865. Are we together? So when you have gotten minus 204.865, that is now the corrected delta nothings on that particular line. So with the same procedure you can do, remember we add 0 here for the second one for delta easting, which means 0 plus 41.149 is still what? 49.149, right? Good. So for delta easting is actually checked. So you follow through as we've explained until you get that of what? Control 2 to control 1. Now for you to check if what you have done is correct, what do? You are going to add everything. Okay, these are the corrected, right? Good. So for you to check if what you have done is correct, you are going to add everything together. So that's the sum, right? Good. So now let's look at it. So the sum of all the values here, including the positive and the negative, actually give us what? 0, which means the delta nothings have been checked, right? Good. Then the sum of all the delta easting, which we have on this other side, is also 0, right? Good. Which means the delta easting has also been checked. So this now shows that we've actually adjusted as we have been requested in the, as it was requested in the question. We've actually adjusted for the delta nothings and the delta easting. So now we are now going to look out for the coordinates of what? Of the new points, right? Good. So we've actually imputed the coordinates of, okay, let's make this this is control 1, right? Good. And then this is what this should be pt1, pt2 down to, let's see how that goes. Let's see how that goes. pt4, right? Good. Then this is what control 2. Good. So we have been able to what? Impute the coordinate of the point given to us, which is this, right? Good. 860.181.523. Okay, there is a 3 here, right? Good. So let's include the 3. Okay, the 3 is still there. Good. 0.523. Good. Then the easting coordinate is what? 600,000.160, right? Good. So we have been able to type out, or we've actually typed the coordinates of the control given to us. Then the next thing is for us to now use the corrected delta nothings and delta eastings to add to or subtract from the coordinate given to us to now get the coordinates of the subsequent point. So what is the drill? The drill is actually use this, the given coordinate of the nothings plus the delta nothings that you've corrected for. It will now give you the coordinates of the new point. So let's now open up this. You now see what it is actually this cell plus this cell. It gave us the answer of this cell, right? Good. Same thing up to this cell. We use the easting of the what? Of the control given to us plus the corrected delta easting we have actually computed for, and it gave us what the easting coordinate of what of point one, right? Good. Coming down to point two, what we now did was that we used the coordinate of point one plus the corrected one on that same line to give us the northern coordinate or the northern equivalent. Coming down to the easting, we use what the easting of point one plus the delta easting corrected on the other on that same line to give us what the easting coordinate. So that's how you go about it. This plus this to give you this plus this to give you this plus this to give you this, and then this plus this to give you what this, right? So you can now see this plus this give you this, right? Sorry, so we are using northern and eastern. It's supposed to be northern and then eastern and what eastern. So with this we have been able to, let's go back to our question. With this we have been able to what we've used the transit rule to actually calculate, or let's say determine the error, and then we've actually also distributed the error by the corrections, right? Good. To the different lines, and we've actually gotten our corrected latitude and the departure, and we've used the corrected latitude and departure on the coordinates given to us of the known point to now get the coordinates of what of the subsequent point. So as we said earlier, if yours does not have any control, definitely there will be the coordinate of one point given to you. So you use that as what the control, and then you now drag down. Excel is actually very interesting. So what we did was just to drag down after the first two has been fixed. So this delta, this nothing plus the delta nothing give us this new one. Then this other new one plus the next delta nothing rather give us the nothings of the new one. That's plus the next one. So that's how we did for the delta eastings, for the eastings as well, down to what? Down to the last point, right? So with this, we believe that we have been able to show you how you can actually carry out traverse adjustment using what the transit rule. We are going to leave on the description section links to other similar videos where you can see how to use your calculator, how to use different methods for traverse computations, and maybe some other related videos that will be very helpful. So you can share with your friends, your colleagues, your students, sometimes your lecturers as well, because almost everyone would want to learn this, right? And it's actually very simple. So thanks for coming to class. We hope we've provided solution to this particular solving problem. If you have any comment, contribution, suggestion, you can leave it on the comment section, or you can send us a message on any of our social media platforms, and we are going to get back to you as soon as possible. And please don't forget to support the channel. We are going to see you on our next video. Until then, keep staying safe and have a very good time. Bye.